Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, May-June 2023, paper 43. Let's start it. Question 1. Some symbol equation and word equation A to J are shown. Use the equation to answer the following questions. Each equation may be used once, more than once, or not used at all. Remember that we will use the letters from A to J to answer the following questions. Photosynthesis is the reaction happened in plant using energy from the sun, where carbon dioxide and water react to form glucose and oxygen. The equation for photosynthesis is J. 2. Addition reaction. Reaction involve the formation of only one product. We have here equation D, where bromine is added on the double bond of the alkene bromine to form one product, which is 1,2-dibromopropane. The third one, precipitation reaction, is the reaction involve formation of a precipitate when mixing two solutions together. We have equation B, where solution contain chromium 3 ions is mixed with sodium hydroxide solution contain hydroxide ion to form the precipitate of chromium 3 hydroxide. Incomplete combustion is a combustion happened in insufficient amount of oxygen to produce carbon monoxide and water. So here we have methane burn in insufficient amount of oxygen to produce carbon monoxide and water, equation G. A displacement reaction. Here we have equation F, where chlorine is more reactive than bromine, so chlorine will displace bromine from its salt potassium bromide, and we will have the products bromine and potassium chloride aqueous solution. The last one, substitution reaction, is a reaction of alkane with halogen in the presence of ultraviolet light. Here we have equation C, where methane react with chlorine to form chloromethane and hydrogen chloride. This equation or this reaction is a photochemical reaction. That means it needs ultraviolet light to happen. It's substitution reaction where one or more hydrogen of the methane is substituted with the chlorine in the presence of ultraviolet light. Question 2. The symbols of the elements in period 3 in the periodic table are shown. Use the symbols to answer the following questions. Again, each symbol may be used once, more than once, or not used at all. Which element is present in the purified bauxite? Bauxite is the ore of aluminium, which is aluminium oxide, so aluminium present in bauxite. Which element contain atoms with full outer shell of electrons? Full outer shell means 8 electrons in the outer shell, so it is an element from group 8. Here we have argon. Is used to kill microbes in water treatment. We use chlorine as a disinfectant for water too in the treatment of water, so we will write chlorine. Which element forms an amphoteric oxide? Amphoteric oxide are oxide which can react with both acid and alkali. So here we have in period 3 we have aluminium. Forms an oxide which goes acid rain. We have sulfur. The oxide of sulfur, which is sulfur dioxide, dissolve in the rain to give acid. Which element has an oxidation number of -1 when it forms a compound with hydrogen? So we have group 7 elements that form ion with oxidation number -1, so we will choose again chlorine. The relative atomic masses of elements can be calculated from the relative masses of isotopes and their percentage abundance. Identify the isotopes to which all the relative masses are compared. All the relative atomic masses are compared to carbon-12. Then we have the table to show the relative masses and the percentage abundance of the two isotopes in a sample of magnesium. We have two isotopes of magnesium. The first one with the relative mass 24 and percentage abundance 85. The second isotope with the relative mass 26 and percentage abundance 15. To calculate the relative atomic mass of magnesium, we will multiply first the first isotope by its percentage abundance, then the second isotope with multiplied again with its percentage abundance. We will add them both together, then divide by 100. The relative atomic mass of magnesium will be 24.3. An ion contains 10 electrons, 13 protons, and 14 neutrons. State the Nucleon number of the ion. The Nucleon number is the total number of protons and neutrons, so we will add 13 plus 14, the total will be 27. The Nucleon number is 27. Identify the element that forms this ion. To identify the element, we will search for the periodic table element with atomic number 13 protons, because elements are arranged according to the atomic number or the number of protons. Element number 13 is aluminium. Then question 3, magnesium form ionic compounds. Magnesium reacts with fluorine to form ionic compound magnesium fluoride. The electronic configuration of atom of magnesium and an atom of fluorine are shown. Here we have the electronic configuration of magnesium atom, 2, 8, 2, and for fluorine it will be 2, 7, because fluorine is in group 7 and magnesium is in group 2. Ions are formed by the transfer of electron from magnesium atom to fluorine atoms. Complete the dot and cross diagram to show the electronic configuration of one magnesium ion and one fluoride ion. Okay, so magnesium is in group 2. The electronic configuration of the atom, as we just said, 2, 8, 2. So magnesium will lose 2 electrons. The electronic configuration of the ion will be 2, 8. And the charge on the magnesium ion will be 2 plus, because now it lost 2 electrons, so we have 2 more protons than electrons. This is the electronic configuration of magnesium ion. For the fluoride ion, it will gain 1 electron. The fluorine atom will gain 1 electron from the magnesium atom, so the electronic configuration changed to be 2, 8, and now we have 1 more electron than proton, so fluoride ion will have a negative charge. So we will go here down. We will draw the magnesium ion with electronic configuration 2, 8 only, with the charge plus 2, and the fluoride ion 2, 8, 7 dots and 1 cross to indicate that this electron comes from the magnesium atom, and don't forget that the fluoride ion has 1 negative charge. Then deduce the formula of magnesium fluoride. To write the formula of magnesium fluoride, we will write the 2 ions with their charges, and then we will exchange the charges, so we will have the formula MgF2. This is the formula of magnesium fluoride. When solid magnesium fluoride is dissolved in water to form a solution, it can conduct electricity. State one other change that can be made to solid magnesium fluoride to allow it to conduct electricity. Because magnesium fluoride is an ionic compound, so it will conduct electricity only when it is molten or in aqueous solution. So the other thing, or the other change can be made to solid magnesium fluoride, is melting. We have to melt it to conduct electricity, because the ions will be free to move. Silicon tetrachloride and silicon 4 oxides are covalent compounds. Complete the dot and cross diagram to show the electronic configuration in a molecule of silicon tetrachloride. We have to show the outer electrons only. So here we have silicon in group 4, so it has 4 electrons in its outer shell. It will form 1 single bond with each chlorine atom, and now the silicon atom has 8 electrons in its outer shell, 2, 4, 6, 8, and then we will count the electrons around each chlorine atom. 6 electrons and 2, they will be 8. So for each chlorine atom we will draw 3 non-bonding pairs. 3 non-bonding pairs means 6 electrons and 2 electrons in the covalent bond with silicon. The melting point of silicon tetrachloride and silicon 4 oxides are shown. As we can see, the melting point of silicon tetrachloride is minus 69, and for silicon 4 oxide it's 1710. Silicon tetrachloride has low melting point because its weak forces of attraction between particles. Name the type of particles that are held together by these weak forces. Silicon tetrachloride, a covalent compound, so the type of particles in the covalent compounds are molecules. These molecules are held by weak forces, that's why it has low melting point. In terms of structure and bonding, why silicon 4 oxide has high melting point? Silicon 4 oxide is a giant covalent structure where silicon and oxygen atom are joined by very strong covalent bond, which of course need high energy to break it. Question 4. Hydrogen is produced by the reaction between zinc and dilute sulfuric acid. Here we have the equation: zinc plus sulfuric acid gives zinc sulfate and hydrogen gas. A student carries out an experiment using excess zinc and dilute sulfuric acid. The student measured the volume of hydrogen produced at regular time intervals using the apparatus shown here. The student used lumps of zinc. So he add lumps of zinc in the dilute sulfuric acid and collect hydrogen gas in the gas syringe, measure the volume of hydrogen at regular time intervals. The rate of reaction decreases as the reaction progresses. The rate eventually becomes 0. Explain why the rate of reaction decreases as the reaction progresses. The rate decreases because the concentration of sulfuric acid decreases by time, so less frequent collision between the particles. That of course will decrease the rate of reaction. Explain why the rate of reaction eventually becomes 0. It becomes 0 because all the sulfuric acid has been used up. The experiment is repeated using powdered zinc instead of zinc lumps, so all other conditions are kept the same. Explain in terms of collision theory why the rate of the reaction increases if we use powdered zinc instead of lumps. Powdered zinc has larger surface area, so more frequent collision between particles and hence increase the rate of reaction. The equation for the reaction is shown between zinc and sulfuric acid. We will use 25 centimeter of 2 mole per decimeter cube sulfuric acid in excess zinc. We want to calculate the volume of hydrogen gas produced at room temperature and pressure. The volume of the gas is at room temperature and pressure is 24 decimeter cube. First, we will calculate number of moles of sulfuric acid. Number of moles for sulfuric acid will be concentration times volume in decimeter cube. So we will convert the volume to decimeter by dividing by 1000, 25 divide 1000, and the concentration is 2 mole per decimeter cube. So number of moles will be 0.05. Then number of moles of hydrogen gas produced, we will refer back to the equation. The ratio between number of moles of sulfuric acid to number of moles of hydrogen is 1 to 1. That means number of moles of hydrogen equal to the number of moles of sulfuric acid. That means number of moles of hydrogen will be also 0.05. Calculate the volume of hydrogen gas formed at room temperature and pressure from the formula. Number of moles equal to volume divide 24, so the volume will be 0.05 times 24 will be 1.2 decimeter cube. This is the volume of hydrogen gas produced. Hydrogen can also be produced by the reaction of zinc with dilute hydrochloric acid. Write a simple equation for this reaction. Zinc Zn plus HCl, the hydrochloric acid, form zinc chloride and hydrogen gas. The correct formula of zinc chloride, zinc ZnCl2 and hydrogen gas H2. Remember, the equation is for 2 marks, so we have to balance the equation by putting 2 in front of HCl. State the test for hydrogen gas. To test for hydrogen gas, we will use lighted splint, and the positive result burns with a squeaky or pop sound. Question 5. This question is about electricity and chemical reactions. Aqueous copper sulfate is an electrolyte, the electrolysis of copper sulfate using inert electrode forms copper at the cathode and oxygen at the anode. State what is meant by the term electrolyte. Electrolyte is a ionic compound which is a molten or aqueous solution that can conduct electricity. State the term given to the Roman number 2 in the name of copper 2 sulfate. This Roman number indicates the oxidation number of copper. State what happened to the color of the aqueous copper sulfate as this electrolysis progresses. In the electrolysis of copper sulfate solution, copper ions, the positive ions, attracted to the cathode where it gains 2 electrons and convert to copper metal. So by times, the concentration of copper ions decreased in the solution. That's why the blue color of the solution fades. So state what happened to the color of the solution, the color will fade. Write the ionic half equation for the formation of copper at the cathode. As we've just said, the copper plus 2 ions gain 2 electrons and convert into copper metals. Give the formula of the ions form oxygen at the anode. The hydroxide ions will go to the anode and form oxygen gas. The electrolysis of aqueous copper 2 sulfate is repeated, but this time we will use copper electrodes, not inert electrodes as in the first experiment. State what happened to the anode. The anode will dissolve or it will decrease in mass. So let's see what happened when we use copper electrodes instead of graphite, the inert electrode. The copper ions from solution will be attracted to the cathode where it gains 2 electrons and deposit as copper metal on the cathode, so the cathode will increase in mass, and the anode will ionize. The anode is also made from copper, so it will ionize to replace the copper ions in the solution, losing 2 electrons and convert into copper ions. So the anode will decrease in mass and finally it will dissolve because it will ionize to replace copper ions in the solution. Spoons can be electroplated with silver. Name a substance that can be used as the anode. To electroplate a spoon with silver, we have to use silver anode, and the cathode will be the spoon that we want to plate it. The electrolyte have to be aqueous solution of silver nitrate, which is the metal that we want to plate with. State 2 reasons why the spoons are electroplated. We can electroplate the spoon with silver to prevent corrosion or to give a shiny appearance or improve the appearance of the spoon. Hydrogen-oxygen fuel cell can be used to produce electricity to power cars. Petrol produces carbon dioxide and carbon monoxide when it powers cars. State 1 adverse effect of carbon dioxide and carbon monoxide. Carbon dioxide produces global warming, and carbon monoxide is a toxic gas because it binds to hemoglobin, preventing it from carrying oxygen. State 1 disadvantage other than cost. Using hydrogen-oxygen fuel cell to power cars compared to using petrol. The hydrogen-oxygen fuel cell has a disadvantage, which is the difficulty in storage, storage and transport of hydrogen gas. Hydrogen need high pressure to store it, so the transport and storage of hydrogen is difficult. Question 6. This question is about nitrogen and compounds of nitrogen. Ammonia is manufactured by the reaction between nitrogen and hydrogen in the Haber process. The equation is as shown. State the source of nitrogen in Haber process. Nitrogen can be obtained from air by fractional distillation of liquid air. The source of hydrogen in the Haber process. Hydrogen is obtained by reaction of methane with steam. So the source is methane. State the typical condition used in the Haber process. Temperature 450 degrees Celsius and the pressure 200 atmospheric pressure. The catalyst used is iron. State what is meant by the term catalyst. Catalyst is a substance used to increase the rate of reaction and remains chemically unchanged at the end of the reaction. Ammonia is converted into nitric acid. The first stage is a conversion of ammonia into nitrogen monoxide. The equation is shown here. The reaction is carried out at temperature 900 degrees Celsius and pressure of 7 atmospheric pressure. The forward reaction is exothermic. Using explanations that don't involve cost, explain why temperature less than 900 is not used. We cannot use temperature less than 900 because the rate of reaction will be slow. As by decreasing temperature, the kinetic energy of the particle will decrease, so they will move slower and we will have less frequent collision, and this of course will decrease the rate of reaction. Then explain why a pressure greater than 7 atmospheric pressure is not used. Here we will refer back to the equation. We have 9 molecules or 9 moles on the left side and 10 moles on the right side. So if we use pressure greater than 7 atmospheric pressure, the position of the equilibrium will be shifted to the left side because the left side has less number of moles, and we will have less nitrogen monoxide. The yield of nitrogen monoxide will decrease. In the second stage, nitrogen monoxide reacts with water and oxygen to produce nitric acid. Balance the simple equation for this reaction. To balance the equation, we will count how many oxygen on each side. Here we have 1 plus 2, 3 plus 1, 4. So we have 4 oxygen on this side and 3 oxygens on the right side. So we will try to make both sides with 12 oxygens. Here we have 4 plus 6, 10 plus 2 oxygen, 12. And we will multiply here by 4. 4 times 3, we have 12 oxygens. Then 4 hydrogen, 2 times 2 is 4. And 4 nitrogen is balanced because we have 4 nitrogen monoxide. A student makes aqueous copper 2 nitrate by adding excess solid copper 2 carbonate to dilute nitric acid. Write a simple equation for this reaction. Copper carbonate CuCO3 plus nitric acid. It will produce copper 2 nitrate, carbon dioxide, and water. Make sure that you write the correct formula of copper nitrate, and you have to balance the equation by putting 2 in front of nitric acid. Write 2 observations that indicate copper 2 carbonate is in excess. We can know that copper carbonate is in excess because copper carbonate remains as undissolved solid at the bottom of the beaker, and no effervescence produced by addition of more copper carbonate. When the reaction is finished, all nitric acid has been used up. Adding more copper carbonate, there is no carbon dioxide produced, so there is no effervescence. Name one compound other than copper 2 carbonate that can be added to dilute nitric acid to produce aqueous copper nitrate. Also, copper 2 oxide or copper 2 hydroxide, any one of them can react with nitric acid to produce copper 2 nitrate. Question 7. This question is about organic compounds. Propane and chlorine react at room temperature, and the equation for the reaction is shown. This is the formula of propane react with chlorine to form chloropropane and hydrogen chloride. State the condition required for this reaction. This is a substitution reaction. The condition needed is ultraviolet light. Draw the displayed formula of 2 structural isomers with the formula of C3H7Cl. One of the hydrogen from propane is substituted with chlorine, so we will have 2 isomers according to the position of chlorine. The first isomer will be 1 chloropropane, where chlorine atom will be on carbon number 1, and the second isomer will be 2 chloropropane, where chlorine will be on carbon number 2. These are the 2 isomers formed. Alkenes are homologous series of hydrocarbons. State 2 characteristics that all members of the same homologous series have in common. All homologous series having the same general formula, the same chemical properties, and the same function group. We can write any 2 of these. Addition polymers are made from alkenes. Here we have this figure to show one repeated unit of the addition polymer formed from butene. Here is the formula of the butene, where the double bond on carbon number 2, and we have 4 carbons, so it is butene with a double bond on carbon number 2. To make addition polymer from but to ene, we have to first remove the double bond, then make a continuation or 2 open ends, 1 from each side. And here we will draw methyl group with each carbon, and the other bond will be hydrogen, like here, and we will leave the 2 ends open. A repeated unit of condensation polymer is shown here in the figure. The polymer is made from 2 monomers. You have to draw the structure of the monomers used to produce this polymer. This polymer is a polyester. Here we have the ester linkage. So this polymer made from reaction between carboxylic group and OH group. To know the monomer, here the first one containing the OH group, and the second one will be with the carboxylic group. So we have 2 monomers. The first one contains 2 hydroxide group, 1 from each side, and the chain is only 2 carbons, CH2, CH2, and 1 hydroxide group from each side. And the second monomer will contain 2 carboxylic groups, 1 from each side, and CH2 in the middle. So this is the carboxylic acid, and this is the diol, and this is dicarboxylic. This is the first monomer, and this is the second monomer. Name the type of condensation polymer. This condensation polymer is polyester. Name the 2 homologous series to which the monomers belong. Of course, this one is a carboxylic acid, and this one, the diol, belong to the alcohol series. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any questions. Thank you for watching. Wish you all best of luck.